Now, this next video is got some cool stuff in it. I'm not going to lie. We've got a residual plot. So the residual from our last problem was 0.16. That was a positive 0.16. When you put 2.5 in, you get a 0.16 residual value. What's important is that we can plot these points. And if in that plot there's a clear pattern, then the model was not appropriate, and that is accurate. If there is a clear pattern, so if residual plot has a clear pattern, then the regression model you chose is not appropriate. You're used to looking at the R-squared value. We are going to look at residuals to see whether or not a regression model is appropriate or not. And this is an example of a residual plot. This residual plot does not have a clear pattern. It's going positive, then negative, then positive, then negative, then negative, then positive, then positive, then negative, negative, positive. This right here would say, this residual plot would say that the model that was used, because there's no clear pattern, the model that was used is appropriate. So this right here would have an appropriate because the model is not a clear pattern. So let me show you a model that is a clear pattern. So out of these three, which ones look like the model is a clear pattern? Think about it, think about it, think about it. Okay, this right here, clear pattern. This right here, very nice pattern. This right here, very scattered. Scattered, no pattern. So remember, when there's a clear pattern, the model that you chose is not appropriate. Pattern equals not appropriate. I should say inappropriate. Appropriate. I don't know why I can't spell this today. Let's say inappropriate. Pattern equals inappropriate. Inappropriate model. Okay, so let's go through these problems. An exponential regression was used to model a data set. The residual plot for the exponential regression model is shown above. So here we go, right there. That's the above. It's on the wrong page. I apologize for that, but this picture goes with this problem. Now, is there a pattern? That's what we're going to ask every single time. Is there a pattern? Yes or no? No, no pattern. So pattern inappropriate, no pattern. No pattern, therefore appropriate. So let's, here we go again. Appropriate. So the exponential model is not appropriate? No, not true. It is appropriate. The exponential model is not appropriate? No, not true. It is appropriate. Exponential model is appropriate. Yes, because the residuals show no pattern. Because the residuals show a pattern. It's going to be no pattern. No pattern. So pattern inappropriate, no pattern appropriate. So this is no appropriate. So you can only have no once. Pattern, no appropriate. No pattern, appropriate. Okay, let's look at the next. A group of AP pre-calculus students used a set of data to create linear, quadratic, and exponential regression models. After creating the 3 models, the students created a residual plot for each model type. Based on the 3 residual plots above, which model was most appropriate for the data? Give a reason for your answer based on the residual plots above. So I'm going to do a little bit of writing here. I'm going to say that this first one shows a pattern. So this is a residual plot. So this is the residuals. This residual plot is most definitely showing a pattern. Therefore, when it's a pattern, the model is not appropriate. Okay, next one. Do you see a pattern? I see a pattern. This looks very sinusoidal. Choo, 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 choo. That is a pattern. Pattern, therefore, model not appropriate. Okay, next one. This model, this residual plot is not showing a pattern whatsoever. It's positive, then it's negative, then it's positive, then it's negative, then it's positive, negative, positive, negative. This is all over the place. Therefore, there's no pattern. Therefore, the model is appropriate. The model is appropriate. So I would say this one right here, the exponential model. Okay, I believe we've got our last problem here. Mr. Passwater hopes to make it to the Guinness Book of World Records by painting the world's biggest mural on the sides of several downtown buildings. His mural will consist of many painted circles of various sizes, where each circle is painted a different color. He wants to create a model to determine how much paint is needed in quarts for a center of radius equal to the number of feet. Should Mr. Passwater use a linear, quadratic, or exponential model in this situation? What should he use? His mural is going to consist of many painted circles of various sizes, where each circle is painted a different color. So he's talking about a circle. Let's see. Consists of many painted circles of various sizes, where each circle is painted in a different color. He wants to create a model to determine how much paint is needed in quarts for a circle of radius r. So the amount of paint needed is going to depend on that radius length, because the circles are pi r squared. That's your area of your circle. So that's how much paint you would need to fill in the circle. That right there is not linear. That right there is quadratic. Quadratic, 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 because the amount of paint depends on the area of the circle, and the area of the circle is quadratic. So the amount of paint depends on the area formula, which is quadratic. Okay, after creating his model, Mr. Passwater uses it to purchase different special paint colors to use on his mural. In this situation, do you think it is more appropriate for the model to underestimate or overestimate the actual amount of paint needed? Give a reason why. So what I'd like you to do is press pause, and I want you to think about whether or not it would be more appropriate to underestimate or overestimate the actual amount of paint needed. Okay, when you're done thinking, you've got an answer even potentially jotted down on your paper, go ahead and press play. Okay, if you said that it is most appropriate for Mr. Passwater to overestimate the amount of paint needed, you would have been corrected. Correct. I would say overestimate to be sure you have enough paint. If you underestimate, then you're going to get stuck with not enough paint and potentially not even having a great color match when you do get the paint. So overestimate to be sure that you have enough paint to get the job done. You'd like a little bit left over rather than even have a little bit left that's undone. So that talks a little bit about residuals and their residual plots. So these plots of the residuals, when there's a pattern, inappropriate model, no pattern, appropriate model. Okay, this concludes our lesson for 2.6. And after this section, we will be moving on to logarithms. So logarithms are just the inverse operation of exponentials. So once you've got one, it's not too bad to get the next one. Once you've got the exponentials, not too difficult to get the logarithms, but it still will be lots of fun. See you in the next one.